Hello everyone. Now again we are here for our next class of Unit 4 Physics, then Unit Work, Energy and Power. Okay, then in last class what we discussed about their energy, type of the energy. Now today we are starting our next topic, power. Okay, then power, what is power? First we will explain this one power. Power is rate of doing work is known as the power. Then we discuss bit of work done when any body is there, then it is moving from one position to another position, then work done from this one to another point, that work done store in form of the energy. Capacity of the doing work is known as the energy. Clear? So this one work as shifting from here to there, then how much work is done in your how much time, that is known as your power. Okay, so here power is the rate of the doing work. We can solve it mathematically. We can say power equal to work done per unit time, that is known as the power. Okay, it is our scalar quantities or quantity. We are dividing into two parts, scalar and vector. So power is your scalar quantity because your work done your scalar only times scalar. When we will divide scalar to scalar, then it will give us scalar quantity only, means not having any direction, it depends on the magnitude. Then unit of the power is watt. Okay, unit of the power is watt. Commercial unit we are using their kilowatt, this one for the power unit. Clear? So here work done, we can power we can say in form of the different, then as body is going from here to there, then how much work is done by this one body in which time, that we can find their power. So how we can write there, if their W work done is there, then here as displacement, this one work done is take place from here to there as displacement, then we can write there, as we know work done equal to force into displacement, that is work done. So from here to there we can write their work done, then power we can write there force displacement divided by your time. So displacement divided by time, this one term we can write there F into V. Okay, displacement divided by time already we discussed in second unit, that is equal to velocity. So power we can write there force into velocity. Clear? Now next topic we are starting bit of power, this only. Now we will start our next topic, collision. Collision is occur when two objects will become in contact with each other, then collision will be take place. This is the event in which two or more bodies exert force on each other in about a relatively short time. When we are bringing a two object, for example, one is body is this one whose mass let we are taking ma. Okay, second body is this one whose mass let we are taking their mb. Clear? Initially it is moving with some velocity u a, then this one moving with some velocity ub, then after some time they will be collide with each other, they will be directly contact with each other. Then as they are coming contact with each other, then after this one they will be move with different velocity but mass will be remain same. ये तो है नहीं कि दो बॉल आप लेके चल रहे, दोनों collide होगी, mass will be transferred from one to another body, but mass will be remain same, only velocity will be vary. And let we are taking this one velocity of these body, we are taking va and vb respectively, final velocity we can say. So during this one case we are writing bit of collision are having two types, elastic collision and inelastic collision. During this collision is take place, then if their momentum and kinetic energy will be remain conserved, then we will call it elastic collision. Okay, initially, that is initial, you can say initial momentum, and here after the collision then it will be your final momentum will be remain conserved. इलास्टिक कोलिजन के अंदर क्या होता है, कोलिजन से पहले जितनी भी मोमेंटम रहेगी बॉडी की, आफ्टर द कोलिजन, कोलिजन होने के बाद जो मोमेंटम रहेगी वो क्या रहती है, कंजर्व रहती है. देयर इज नो लॉस इन द मोमेंटम. मोमेंटम के साथ साथ क्या होता है, एनर्जी में भी कोई लॉस नहीं होता. इधर जितनी भी एनर्जी रहेगी बिफोर द कोलिजन, दिस वन केस बेटा बिफोर कोलिजन and this one here after collision. After collision. So if this one will follow both law of the conservation of the low linear momentum as well as the law of conservation of the kinetic energy, then we will call it elastic collision. And for beta this one, we will define this one elastic collision also by using your coefficient of restitution. What? Coefficient of restitution. Coefficient of restitution. What is coefficient of restitution? That is a ratio of the change in final velocity. How much change in the final velocity to the initial velocity? That ratio is known as the coefficient of the restitution. If this one ratio is coming equal to 1, then we can say this one here collision will be elastic. If not coming equal to 0, then we will call it inelastic collision. So here in elastic collision, but a second type of the collision where there is a loss of the kinetic energy. Means elastic कोलिजन में हम बात कर रहे हैं कि इनिशियल कोलिजन से पहले जितनी भी एनर्जी रहेगी आपकी यहाँ पे और आफ्टर द कोलिजन जो एनर्जी रहेगी वो क्या रहेगी, सेम रहेगी. बट इलास्टिक के इनइलास्टिक के अंदर क्या रहता है, लॉस इन द काइनेटिक एनर्जी. काइनेटिक एनर्जी के अंदर क्या हो जाता है, लॉस हो जाता है. दैट दे विल नॉट मूव विद दीज वेलोसिटी. So if the loss will be there, then we can say it will not follow the law of conservation of kinetic energy. Kinetic energy. So those objects which are not following law of conservation of kinetic energy, then we will call it inelastic collision. जो आपको follow करेंगे law of conservation of momentum को और kinetic energy को, उनको क्या बोलेंगे, elastic collision. So next we will do this one. Here you can say beta there the difference between elastic and picture you can say elastic and inelastic collision. अगर आप ये ball से इनको strike करोगे then ball will move here and there. Okay, as we are taking this one ball को touch करके जैसे इसके कम contact में आएंगी for the short time they will collide, then each ball will be collide with this one ball. Okay, so before the collision, after the collision, then both will follow their law of conservation of momentum as well as the kinetic energy. There is no loss of the kinetic energy. But in that case, beta, this one car strike with this one, then velocity will be not remain same before the collision. That's why there is a loss of the kinetic energy. It will not follow the conservation of the kinetic energy. So this one here inelastic collision, this one will be your elastic collision. So next we will find their elastic collision. How we can find their velocity in the elastic collision after this collision? Then here let we are taking their two masses. We are taking their m1 and second mass we are taking their m2. Then initial velocity of this one mass, let we are taking u1. After some time its velocity become u2. So let here we are writing, let two masses and m2 moving with initial velocity u1 and u2, and after collision its final velocity becomes v1 and v2 respectively. Okay, then before the collision we are taking this one condition. Before collision, आफ्टर दिस वन दे विल कोलाइड विद ईच अदर. अगर इसकी स्पीड क्या रहेगी, इससे ज्यादा रहेगी तो कुछ टाइम के बाद क्या करेंगे, कोलाइड कर जाएंगे. देन आफ्टर कोलिजन देन स्पीड विल बी चेंज बट मास विल बी रिमेन सेम. ओके, इट्स मास इज m1, तो कोलिजन के बाद भी क्या रहेगा, इसका मास m1 ही रहेगा. लेट वी आर टेकिंग ऑफ दिस वन बॉडी m2 मास, देन इट्स मास आल्सो विल बी रिमेन सेम बेटा, बट वेलोसिटी विल बी वेरी आफ्टर द कोलिजन. देन लेट इट्स वेलोसिटी बिकम्स v1 and this one velocity v2. So these two velocity we have to find out using this one कि अगर कोई भी दो बॉडी कोलाइड होती है तो कोलिजन के बाद उसकी वेलोसिटी में कितना चेंज आएगा, कितना वेरिएशन आएगा. So this one we have to find out to find v1 and v2. Clear? So this one is the example of the elastic collision. So it will follow your during elastic collision. It will follow law of conservation of linear momentum. Second one, law of conservation of kinetic energy. So we will use both law in the collision. In elastic collision, how we can solve these collision. Then here we will take beta before this one. Means here this one in the collision we are writing there total linear momentum, initial linear momentum equal to total final momentum of the both body. Here initial momentum we can say their mass of this one body is m1, then momentum we can write their mass into velocity. So initial momentum of this mass we can write their mass m1 u1 velocity. Of this one your momentum of this one body we can write it your mass is m2 and velocity is u2. This one here initial linear momentum of the second body whose mass is m2. This one your m1, after the collision its velocity becomes v1, so its momentum we can write there m1 v1. Final linear momentum of mass m2, m2 v2. So we have written the momentum of each bodies before the collision, after the collision. Then we will apply these terms in your law of conservation. This one, law of conservation of linear momentum. Okay. Now, law of conservation of linear momentum, we can say total initial momentum equal to total final momentum. Initial momentum we can write there your P1 plus your P2. These are the initial momentum equal to the M2, M1 mass, M2 mass, final momentum. Okay, after the collision you can say initial किसकी बात कर रहे हैं before the collision and final किसकी बात कर रहे हैं after the collision. This one final momentum is after collision. So here we will write their initial momentum of this body m1 mass v1 velocity plus p2 m2 mass u1 initial velocity is u1 and here u2 is the initial velocity of the second body, and here final after the collision m1 v1 plus your m2 v2. We are writing this one. So as we are taking this one m beta we are writing there one side, that's why we can take common from here. Then m1 u1 minus your m1 v1 equal to your m2 v2 minus m2 u2. m1 you can take common from here, u1 minus v1. This one left. M2 you can take common from here, V2 minus U2. Okay, this one our first equation as we are using their law of the conservation of linear momentum. So now we are applying their law of conservation of the energy, law of conservation of kinetic energy. Now, before the collision, we can say total initial kinetic energy equal to total final kinetic energy. This one before collision we can say कंजर्वेशन का मतलब क्या होता है बेटा, कोई भी लॉस ना हो, जितनी इनिशियल काइनेटिक एनर्जी उतनी क्या रहे आफ्टर कोलिजन रहे, देयर इज नो लॉस ऑफ द काइनेटिक एनर्जी आफ्टर कोलिजन। दोनों जो टोटल काइनेटिक एनर्जी है वो हमारी क्या है, सेम रहेगी, कोई भी लॉस नहीं हो रहा। सो हियर वी कैन राइट देयर इनिशियल मोमेंटम काइनेटिक एनर्जी, initial of first body kinetic energy, initial of the second body, then kinetic energy of first body plus your kinetic energy of the second body, this one of the final kinetic energy. So we are writing here this one kinetic energy. We know that if mass is m, v is a velocity, then we can write there half mv square. So initially mass m1, velocity we can write there u1 square plus 1 by 2 m2 mass u2 its velocity equal to kinetic energy, final kinetic energy of mass m1 v1 square plus 1 by 2 m2 v2 square. Okay, so from here we can take common beta half common if we are taking, then this half, this to this half cancel out. यहाँ से हाफ कॉमन निकालिए, इधर से हाफ कॉमन निकालिए, दोनों साइड से हाफ हाफ कैंसिल हो जाएंगे। तो यहाँ क्या बचेगा आपका m1 u1 m2 u2. So this one take one side m1, m2 take one side. If we are taking one side, then we can write there m1 common u1 square minus v2 square. इसको इधर ले आए, so this one will be minus. So here m2 then v2 square, इसको इधर लेके जाएंगे तो क्या आएगा, initial velocity of the second body. Clear? I hope you understood beta till here. Then after this one, this is our second equation. Our first equation came this one. First equation क्या थी, ये वाली थी. This one we are writing on the next page. So here we can write there m1 u1 minus v1 equal to m2 v2 minus u2 as it is copy किए बेटा, ये मैंने लास्ट पेज से फर्स्ट इक्वेशन की. ओके, दिस वन आवर फर्स्ट इक्वेशन, दिस आवर सेकंड इक्वेशन. सो here we have to find out ratio of these velocity. So how we can find there, open this one formula. This formula we can write there a square minus b square, we can write there a plus b, a minus b. So as we are opening this one, then we can write there second equation. Then second equation we can open this one m1 from equation second m1 u1 minus v1, then u1 minus v1 u1 plus v1, a plus b, a minus b, this one formula we are opening. Then m2, then here formula will be v2 minus u2. Now here open this one a square minus b square, a plus b, a minus b. So here we can write this one v2 minus u2, v2 plus u2. Clear? This one our second equation. Second equation के फॉर्मूले को हमने ओपन कर लिया. अब हम क्या कर रहे हैं, now this one our third equation we can write there. This one our third equation. So divide equation 3 by first equation. Clear? So now we are writing this one third equation, u1 minus v1 u1 plus v2 equal to your m2 v2 minus u2 v2 plus u2. Okay, so on the last page your first equation is this one. We are writing this equation m1 v1 minus u2, then this one divide by this equation, then our equation will be m1 u1 माइनस v1, यही इक्वेशन थी ना, चेक कर लेते एक बार, u1 माइनस v1 एंड v2 माइनस u2, v2 minus v2. Okay, now this to this cancel out, this to this cancel out. So here left m से m भी cancel हो रहा है बेटा, इसको भी cancel कर देते. So here left u1 plus v1 equal to v2 plus your v2. Okay, now as we will solve this one, ratio we have to find out बेटा. तो ratio क्या आ जाएंगे here, final velocity minus initial velocity, and this one we can write there, u को एक साइड ले आओ, फाइनल वेलोसिटी को एक साइड ले जाते हैं, तो इसको इधर लेके आएंगे, देन दिस वन इज इक्वल टू योर v2 माइनस v1, इसको इधर ले आए, इसको इधर ले आए, तो यहाँ से ये टर्म आ गई बेटा. सो दिस वन रेशियो वी कैन राइट देयर 1 इक्वल टू, इसको इधर लेके जाएंगे तो इधर क्या बचेगा 1, v2 माइनस v1 u1 माइनस u2. क्लियर? सो रेशियो ऑफ चेंज इन फाइनल वेलोसिटी टू द इनिशियल वेलोसिटी इज equal to 1, that is known as coefficient of restitution, that is coefficient of the restitution. Okay, so according to coefficient of restitution beta, what is this one, how we will write its definition, ratio of the change in final velocity to the change in initial velocity. ये ध्यान रखना बेटा, v2 minus v1, v1 minus v2. Okay, so coefficient of restitution क्या होता है, coefficient of restitution, ratio of, it is defined as